Have you ever stopped and wondered what artificial intelligence really is? I mean, beyond the sci-fi movies. It sounds so complex, right? Well, I promise you, by the end of this short explainer, you're not only going to get it, you'll realize you're already an expert user. So let's just dive right in.
All right, here's our game plan. First, we'll look at the AI that's literally in your pocket. Then, we'll pull back the curtain on how it learns from data. We'll check out the 3 main ways machines learn, then we'll peek inside an artificial brain. After that, we'll meet the incredible new creative AIs, and finally, we'll think about what this all means for our future.
Okay, first things first, let's make this real. This isn't about robots in the distant future. AI is already here, and it's a huge part of your daily life.
I mean, seriously, think about your day so far. Did you unlock your phone with your face? That's AI. Asked Siri or Alexa about the weather? AI. Got a movie recommendation from Netflix or saw that little red line on Google Maps predicting a traffic jam? Yep, all AI. It's suggesting what you should buy on Amazon, and for the coders out there, it's even helping you write code. We are absolutely swimming in it.
So, what is this stuff really? Well, at its core, AI is just technology that lets computers do things that, until recently, only humans could do. Things like spotting patterns, understanding what you're saying, or looking at a photo and knowing, hey, that's a cat.
So, how do these things get so smart? What's the secret sauce? Well, the secret ingredient is data, mountains of it, and the method is something called machine learning. Let's see how this all connects.
You know, the best way to think about this is like a set of Russian nesting dolls. The biggest doll, the whole field, is artificial intelligence. But inside that, the part that's really driving everything today, that's machine learning. And a really powerful part of that is called deep learning. And deep learning is what powers all the amazing new generative AI tools we're hearing so much about.
And this is the big aha moment. In old school programming, we had to write out all the rules. We'd give the computer an input, and we'd give it the exact logic for what to do. With machine learning, the whole game has changed. We just give it the input and the right answers, tons and tons of examples, and the computer figures out the logic all by itself. It writes its own rules. It's basically a 2-step dance. The first step is training. This is where the AI studies a massive data set. For example, a bank might make it analyze every loan application it's ever received. Then comes step 2, inference. Now the AI uses the patterns it learned, we call that the model, to make predictions on brand new data, like deciding whether a new person should get a loan. So we know machines learn, but it turns out they don't all learn the same way. There are 3 main styles, and each one is pretty cool in its own right.
First up, we have supervised learning. The best way to think about this is like studying for a test with a complete answer key. You give the machine a giant data set, where every single piece of information is already labeled with the correct answer. It takes a ton of human effort to create that labeled data, but it's incredibly powerful. The perfect example, your email spam filter. It was trained on literally millions of emails that real people had already marked as either spam or not spam. By looking at all those examples, it started to learn the telltale signs of a spam email all on its own.
Okay, next we have unsupervised learning, and now we take away the answer key. We just give the machine a giant, messy pile of data and say, go figure it out. Find the patterns. Group the stuff that seems to belong together.
So, imagine you dump thousands of random news articles into a system. Without any help, it would start to notice that some articles use words like smartphone and software and group them into a technology cluster. Others mention elections and government, and they become a politics cluster. It discovers the categories all by itself.
And the third style is reinforcement learning. This one is all about trial and error. You have an AI agent that you put into an environment, like a character in a video game. It gets rewarded for good actions and penalized for bad ones. Its one and only goal is to rack up the highest score possible. It is exactly like training a dog. At first, the dog has no idea what sit means. But when it accidentally plops its butt down and you immediately give it a treat, a reward, its brain makes a connection. It learns that the action, sit, leads to a good thing. That's reinforcement learning in a nutshell.
Okay, now let's get a little deeper. Remember that deep learning circle we saw? Well, we're about to look inside at something called neural networks, which are systems loosely inspired by the wiring of our own brains.
But before we get too technical, let's use a super simple analogy, how your final grade in a class is calculated. You have your inputs, right? Your scores on different tests and assignments. Each of those has a weight.
The final exam is worth more than a pop quiz, for example. And then a formula combines all those weighted scores to produce a single output, your final grade.
Believe it or not, a basic neural network works in a very similar way. Data goes in as inputs, the network gives each piece of input an importance, a weight. Then it combines them to make a prediction. But here's the magic part. It can then check if its prediction was right or wrong and go back and adjust all those weights over and over, getting a tiny bit smarter with every single attempt.
This training process has a kind of rhythm to it, a forward and backward flow. First, it goes forward. Information flows through the network to make a guess. Then, it calculates its loss, which is just a fancy word for how wrong it was. Finally, it works backward, sending a signal all the way back through the network to tweak the weights just a little bit so it does better next time.
And all of this complex learning has led to something truly revolutionary, generative AI. This is where AI takes a giant leap. It's no longer just analyzing or predicting things. It's actually creating brand new things from scratch.
I'm sure you've heard of these tools. You've got ChatGPT that can write a poem, Gemini that can plan your vacation, Midjourney that can create a work of art. And it's not just for fun. Tools like GitHub Copilot are changing how software gets made, and things like Sora are totally rewriting the rules for video. This is all about boosting human creativity. And the results are just mind-blowing. You can give a model a prompt for something completely absurd, something that's never existed, like a sloth in an astronaut helmet, and it will just create it, a completely original, high-quality image. This is way more than a party trick. It's a fundamental change in how we create and interact with computers.
So that brings us right up to today. We've gone all the way from the AI that's hiding in plain sight on your phone to the deep mechanics of how these systems learn, predict, and now how they create.
So we've built these incredible machines that can learn, that can predict, and that can create. The technology is here, and it's getting better every single day. So the biggest question, the one we all have to think about now, is no longer how they work, but how we're all going to work with them. The next chapter, well, that's not about the code. It's about us.